that you open a savings account with an interest rate of 5% per year compounded annually, and that you plan on contributing to the same amount to it at the start of every year. Calculate how much the account would have after the deposit at the start of the 50th year if the amount invested each year were $100, $500, $1,000, or $2,000. Oh, yesterday we learned about this formula. Okay. And we learned that A is our initial and R is our rate. This is going to be similar to like that one that we did last time. It's going to be just like that other one. Our initial is going to be 100. And our R is not going to be just that 5%. It's going to be 1.05. Okay. The reason why this is going to be 1.05 is because we want to gain money, right? We're not losing money. So this has to be more than 1. Okay, so we've got 100% of the money that we've already taken into consideration plus the 5%. So that's why it's 1.05. On the bottom, we're going to have 1 minus 1.05. Okay, so now that we've plugged that in, we're going to go to Desmos. And we're going to type all that mess in. So we're going to have 100 times, there you go, 1 minus 1.05. And we're going to raise that to the 50th. And then we're going to divide it. This is on page 5. Oh my goodness. There we go. Divided by 1 minus 1.5. Okay, so we're never using the Desmos calculator on my phone ever again. All right, so after 50 years, we would have $20,934 and about 80 cents. Can you try if you initially put in $500? Okay, so same formula, only thing that you're going to change is that A. Take a moment, try that one. Next one. So we're going to plug in 500. We're going to plug 500 in. We're going to have 1 minus 1.05 raised to the 50th over 1 minus 1.05. What'd y'all get when you plug this in? Yep. Okay, so you know how you're putting in on this original problem, you're putting in $100, and the next year you're also putting in $100, but you're also getting that 5% added onto it. It's gonna be 1.05. Yep. So if we plug in 500 instead of 100, we're gonna get 104,373 points. We're gonna just say 99. So the more that we're investing, the more we're making, right? If we do 1,000, same setup. And we plug in 1,000 for our initial. Then we're going to end up with 209,347.99 roughly. So the more that you invest at the beginning, the more you're going to make at the end. All right, so using this formula, we're going to write a formula to find the sum for the total value of the terms in the list after the nth term. Okay, so the first thing that we want to do is we want to find the rate. The way you find your rate is you take your second term and you divide it by your first term. Okay, so in this instance, we have 12 divided by 48. We can simplify that to what? Well, we can divide the top by 12, and we can divide the bottom by 12. So that's going to give me 1/4. So our rate's going to be 0.25. Okay, because 1/4 is in decimal form, 0.25. Okay. Now, we're going to substitute that into this equation in order to write out a formula for how we would find the sum of the first terms. So first we're going to write S sub n. And what was our initial? What was our first term? 48. And then we have 1 minus, and our rate was 0.25. I know on the last problem, we had 1.05. In this case, we are decreasing, so we're not going to put a 1 in front. Okay, so this is going to be 0.25 raised to the n, and we're going to divide it by 1 minus 0.25. All right, so now we're going to find our we're going to use our formula to find the total value of the list after the 10th term. Okay, so we're going to plug in 10 into our equation. So we got S sub 10 is equal to 48 times 1 minus 0.25 raised to the 10th divided by 1 minus 0.25. And we're going to take that, and we're going to plug it into decimals. So we got 48 times 1 minus 0.25 we're raising it to the 10th power. And then we're going to divide it by 1 minus 0.25, which is just 0.75. So this would give us 63.99, which is about 64. Yep, go ahead. Trickier. They give us a little weird of information. Okay, so they said find the sum of the first 15 terms of a geometric series, given the first term is 2 and the third term is 32. Okay, so first term is 2 and the third term is 32. All right, so we know that we're increasing, but we don't know what we're like multiplying by each time. Is there any number that I can multiply 2 by, get a number, and then multiply it by it again and get 32? All right, well, let's try a couple different things. Well, 2 times 1 wouldn't get us anywhere, right? What about 2 times 2? What would that give us? 4. And then 4 times 2 again, would that give us 32? Okay, so that wouldn't work. What about 2 times 3? That would give us 6, right? 6 times 3, would that give us 32? Nope. What about 2 times 4? That would give us 8, right? And 8 times 4, would that give us 32? Yeah. Okay, so we know that the rate is going to be 4. So the rate is going to be 4. All right, so now we're going to substitute all of our information into our equation. So how many terms are we trying to find? Okay, so this is going to be S sub 15, because there's an n right here, is equal to, what's our initial? 2. And we're going to have 1 minus, what was our rate? 4. And we're going to raise that to the 15th power. And we're going to divide it by 1 minus 4. So I'll give you a second to write that down. When we substitute this into Desmos, we're going to get, this is the sum of the first 15 terms. This is going to give me 715,827,882. Voila. The ratio between terms is in a given series is 5. The sixth term is 21,875. Find the sum of the first 8 terms of the geometric series. Again, this one's a little trickier. So we have 2, 3, 4, 5. Our sixth term is 21,875. They tell us that our ratio is 5. Okay, so that means that multiplying up, we're multiplying by 5 each time. If I want to find the previous term, what am I going to do? Divide by 5. Okay, so we're going to take 21,875 and we're going to divide it by 5. And that gives us 4,375. If I want to find the previous term from that, I'm going to divide by 5 again. That's going to give me 875. If I want to find the previous term from that, I'm going to get 175. Why am I doing all this work? What am I trying to find? Ultimately, yeah, we're trying to find the sum, but what do we need in our formula in order to find the sum? The initial amount, right? So if I divide that 175 again, I'm going to get 35. And if I divide it by 5 again, I'm going to get 7. So our initial amount is 7. They tell us that our rate is 5. And then they tell us that they want us to do the first 8 terms. So we're going to plug all of that information into our formula. So we're going to say S sub 8 is equal to 1 minus 5 raised to the 8. Oh, and our initial amount was 7. On the bottom, we have 1 minus 5. All right, so we're going to plug all of that into our calculator. And when we do that, we're going to get 683,592. Ta-da. All right, so let's kind of talk through this together. I'm more of a visual person. I like to see what I'm actually being asked to do. So they say 8th term and the common ratio is 2. I use those little blanks to help me. So we got 8 little things. That's 5, 6, 7, 8. And our 8th one is 384. Now, when we multiply up, we're multiplying by 2. So that means that if we're going backwards, we're going to divide by 2, right? So we're going to take 384, divide it by 2. That's going to give me 192. Then the next one, divide by 2. 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 So what's my initial term? 3. Yay. How many of y'all got that right? Yes. Okay. All right. So this one always stumps people. They're like, I don't even know where to start. So let's kind of talk through this one. So we got first term is 5. Don't know second. Don't know third. Don't know fourth. And the 5th term is 405. So we need something that we multiply by to get us up to 405. So we can start off with 1, but that's not going to do us any good. What about 2? Is 2 going to work? Probably not, because we're going to end up with 405 at the end. What about 3? Well, we can try that. We're trying 3. So 5 times 3 is 15. 15 times 3 is 45. And then 45 times 3 is 135. And 135 times 3 is 405. Dang, I'm a good guesser. Look at me. So what was our ratio? 3. On this one, you kind of have to, like, I don't want to say guess and check, but that's kind of what you have to do. You could create a formula for this. You could say your initial is 5, and then figure out what your ratio is by plugging in a number, and it would produce a table. But you could also just do it this way. That might be easier.